Good morning, geometry class, and welcome to another lesson. Today we're going to be working on 11.2, which has to do a little bit more with proportions and similar triangles. And so let's say that these were the values of three sides of a triangle. The question is are they proportional? And if they are, what is K? There's a couple of different ways that we can go about doing this. Remember that we already talked about how yesterday lesson was based on image divided by pre-image and setting up those proportions. The image prime over the pre-image prime is equal, should be equal, proportionally equal to image prime divided by the pre-image. So in this particular case, there's a couple of different ways we could go about doing this question. The first is do these all have a similar K factor? And so I'm going to use this first one, which is proportional, to set the standard by which we're going to learn two different methods. The first thing is if we had 24 from the image, and then we divided that by the pre-image of 8, what would the K factor be? Well, 24 divided by 8 is 3. So does that work for all three sides of the triangle? Well, 8 times 3 is 24. We already established that. 5 times 3 does equal 15, and that works too. And 7 times 3 is 21. So you'll see that 3, the K value 3, works for 8, 5, and 7 to correspond to 24, 15, and 21. But that's not the only way we could prove this to be true. We can also use this method by saying that it's 24 is to 8 as 15 is to 5. And if the proportions are accurate, this should work out. Well, we should be able to cross multiply. So we get 24 times 5 should be equal to 15 times 8. So we get out our handy dandy trusty calculator, and we do 24 times 5, and we get 120. And then we do 15 times 8 is also 120. So if the proportions work out, and it can't just work out for two of the sets, it has to work out for all three. So you'd want to do that same process again, like with 24 and 8 as to 21 and 7. So in this case, you'd have, let me put a divider here, 24 times 7 should also be proportional to 21 times 8. 24 times 7 is 168, and 21 times 8 is also 168. So they are proportional, and they all have the same K factor of 3. So now we have two other questions that we're going to work on here. And the next one is, are 2, 3, and 1 proportional to 8, 10, and 4? Well, the first thing that as I'm looking at this, I want to see that this is the smallest, largest, and medium. Do those match up? Yep, medium, large, small, those match up. So now we'll work with our image over pre-image. So we'll say 8 is to 2 as 10 is to 3. Does that work out? So if we cross multiply, we have 8 times 3 is to 2 times 10. In this case, you'll see that on the one side you have 24, and on the other side you have 20. Those are not equal. These are not proportional. I probably should have finished the top problem. I did talk about it, but I didn't write it down. These are proportional. And with being proportional, the scale factor, the K factor, is equal to 3. Now let's work on our last question. And again, we're going to look and see if they're proportional. I got small, medium, large, and should have small, medium, and large. So let's start working, and let's put the image of 3 over 6. Now, this one was an enlargement. These ones were not proportional, so it doesn't matter. But if this works out, this is going to be a contraction. Okay, so 3 is to 6 as 6 is to 12. So if I cross multiplied, I'd have 3 times 12 is equal to 6 times 6, or 36 is equal to 36. So there's a good chance that these will be proportional. But again, I really want to try this again for, let's do the small and the large. So with the small, it's 3 is to 6 as 8 is to 16. Again, I put the image over the pre-image. So when I cross multiply, I'm going to get 16 times 3 is equal to 8 times 6. 16 times 3 is 48, and 8 times 6 is 48. So it worked here, and it worked here. So yes, these guys are proportional. And again, it's not an enlargement, it's a contraction. And we want to find the K factor, and we find the K factor by taking the image divided by the pre-image. I feel like I've said that a lot lately, and I'll continue to say it until we've got it. But in the image, let's just take the small values. We should be able to take the mediums or the large and get the same thing. The small value, we have the image value, we have 3. And the pre-image, we have 6. So 3 divided by 6, K would equal, we can reduce that to 1/2. K equals 1/2. Okay? So I showed you one that's not proportional and 2 that are proportional, one being enlargement, one being a contraction. There are 3 ways. We talked about 3 ways to prove that triangles are congruent. There are 3 ways to prove that triangles are similar. In today's lesson, don't worry, you're not going to have to do proofs all by yourself, geometric proofs. We're just talking about the three concepts, the 3 lettering systems that we can use to prove that triangles are similar. They're a little bit different than proving that triangles are congruent, but they are, and I don't use this word, I use this word tongue-in-cheek, they are similar to the proofs that we use to prove that things are congruent. Now, you can never use angle to prove that triangles are congruent, but you can use angle to prove that triangles are similar. And this is the case on this side. This is angle. Because let's just say, for kicks and giggles, that this here was a 50-degree angle, and that this was a 50-degree angle. Those can have the same angle measure, even if a dilation has occurred. Because you'll remember from last chapter that dilation preserves angle measure. So then let's say that this angle up here was 70 degrees. 70 degrees. What's the sum of the measures of a triangle? Well, they equal 180, and they're going to equal 180 in both triangles. So one triangle would be x plus 50 plus 70, and the other triangle would be x plus 50 plus 70. You could see clearly in both cases that the third angle is going to be the same. No matter what if the first 2 angles are congruent, you're guaranteed that the third one's going to be congruent also. We learned that earlier in the year when we said angle implies that all three angles are congruent. So in order to prove that things are similar, all you really need is knowing that two angles are similar. Then you know are congruent, then you know that the whole triangles will be similar. In this case, your third angle would be 60 degrees. I hope that makes sense. Another way to prove that angles are similar is this diagram here. You can see that if you take 5 and you multiply it by a scale factor, a k factor of 4, 5 times 4 equals 20, and you take 4 and you say 4 times 4 equals 16, that those are proportional. They're similar. We could also say 16 over 4 is equal to 20 over 5. If we cross multiplied, we would get 80 equals 80. So they are similar. So because the sides are similar and the included angle, that means the angle has to be in between the sides. If it was an angle up here, that doesn't work. That's not side angle side. But in this particular case, we are looking at side angle side. The sides are similar and the angles are congruent. I'm going to put that. Sides are proportional, similar, and the angles are congruent. That means that you're going to have a k factor between a similar k factor between the image and the pre-image, but if this angle is 30 degrees, this one must also be 30 degrees because according to last chapter, in a dilation, angle measure is preserved. Okay? What am I? Oh, this is the same slide. I have no, it's not the same slide. If we look at this one, is this one side angle side? Let's just kind of look at this. The angles are congruent. It states that with one hash mark. That's what that means, is that these angles are congruent. Now let's take the image over the pre-image and see if these are proportional. Okay, let me erase that little hiccup and let's work this out. So if we take 16 over 8 and set it equal to 24 over 6, are they proportional? Well, let's do a little bit of cross multiplication. 16 times 6 is 96. And 8 times 24 is 192. Are these proportional? No. This looks like side angle side, but it's not similar. So on your homework tonight, you're going to say, are these two shapes, the image and the pre-image, are they similar? And if they are similar, tell us why. So on the last slide, yes, these are similar because of side angle side. No, these are not similar because the sides are not proportional. Let's move forward. Here, if we looked at this one, it's not angle because there's no angles that we know are congruent. It's not side angle side. The only possibility is that this could be side, side, side. Well, if it's side, 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 there's a couple of methods. Either we could use the proportional method or we could use the K method. Because the last slide I used the proportional method, this time I'm going to use the K method, seeing if they are proportional by the same scale factor of K. So I'm going to take image, and they're all based on the same thing. Image divided by the pre-image. So if we take the image of 25 and we divide by the pre-image of 5, we get our K factor to be 5. So in order for this to truly be side, 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 you have to be able to multiply each pre-image by 5 to get the image value. So 5 times 5 is 25. So 5K5 does equal 25. 3K5 does equal 15, and 2k5 does equal 10. So because all the pre-images multiply to 5 in the image, we would say yes, these are proportional because of side, side, side. Let's keep moving forward. Let's use this knowledge that we've gained in a word problem. Here we have, as we look at this, I kind of like to set this up as a familiar Bible story. Let's say that David, the shepherd boy, was 6 feet tall. And then we read in the Bible that Goliath was this monster of a man who stood 9 feet tall, according to what the Bible says in the measurement of cubits and figuring them into feet. I'm just speculating. We don't know that David is 6 feet tall. Let's just speculate. And I just want to kind of use this as a story. Let's say that, one of David's brothers is sitting back here looking across the valley in which this battle, looking up at David as this battle is taking place. We see two similar triangles are formed. And I'm going to outline these similar triangles for you. Here is a triangle that is similar to this triangle here. And I could state that because of angle. But let's just say that we have two similar triangles. And we want to find what x is. So what I would do is, if I was doing a problem like this, I would begin by sketching those two triangles. So the triangle that I highlighted in yellow had 4 and 6, and you could have the right angle be your similar angle. And then the triangle that I highlighted in red, the similar one, you had 9, and this was a right angle. I know I did a terrible job sketching that. But what's the base of that angle? Is it x? I believe if you said it was x, you'd be wrong. Because isn't it actually, if you read the diagram correctly, isn't it x plus 4? Wow. Now we can set this up as a proportion to try and solve for x. So we'll say the image, let me get out a different color here, of 9 is the pre-image of 6 as the image x plus 4 is to the pre-image of 4. Now we're going to cross multiply just like we have before. So we're going to have 9 times 4 equals 6 times x plus 4. 9 times 4 is 36. And 6 times x plus 4. Because x plus 4 and 6 are both factors, we're going to multiply those together. There are two methods at which we could work this problem out right now. The one that I'm going to do will be proven to be easier to do in all problems, whereas the second method, where you just divide the factor of 6 across, would only be really simple in this one. It could be confusing on some other ones. So I'm going to use the distributive method here. So we're going to say 36 equals 6x plus 24. So I distributed the 6 to both terms. Now what I'm going to do is I'm going to subtract 24 from both sides. When I do that, I get 12, because 36 minus 24 equals 12. So 12 equals 6x. So x equals 2 feet. All right? So that would be 2 feet is what x is. All right? Hope you understood that. You'll probably have one like that on your homework tonight. Here's another one. Again, I've set up the similar concept with a diagram to kind of help you. And so we will, just like last time, we'll create two triangles. So I'm going to have an orange triangle here. And its similar triangle we'll make in blue. I missed March Madness this year. It was probably a good thing because I don't think Syracuse Orangemen were going to be in the tournament at all. And I miss watching Syracuse Orangemen. I've picked them every year to win the bracket. It only worked out once for me, Carmelo Anthony. But we want to find out how tall this flagpole is. You know that here's a crazy thing. I've actually in my life, I know this isn't something you do every day, and probably none of you guys on your vacation you're going to go out and do this, but this is something I've actually done to try and figure out how tall a tree is. But let's say we had a similar angle of inclination, we lined things up. We could calculate how tall this flagpole is by using similar triangles. I know you might say, I'll never use this in life. This is something I actually have used in life. You don't have to. There are other ways to find out how tall a tree is. You can get a tape measure out, but if a tape measure isn't handy and you want to know how tall a tree is, this is something you could use. Let's say that I'm 6 foot. I'm a little shorter than 6 foot. I'm probably 5'11". But let's just say I'm roughly 6 foot. If I lined myself up with a straight line, I took somebody and I had them look straight up at a tree and line me up, you could calculate how tall that tree is without a ruler from standing on the ground using similar triangles. So I'm going to make two triangles. I'm going to make one of them orange. Signify that I got that orange one. I'm going to make one of them blue. So on my orange one, I know that the base is 10. The height is 6, and so we have side, angle, side, okay? And another similar triangle, all these angles should be the same. That's why this would work out. But if the base is 150, reading my diagram correctly, remember last time it was like x plus, but if I've got to carefully pay attention to the diagram, I'm going to see that it's 150. We're going to say the height of the flagpole is x. Can we calculate x? Absolutely. We could use proportions in order to do that. Last time, I set up them proportionally. This time, I'm going to use another method. I'm going to look here, and I'm going to say what number multiplies, and I don't want to just guess, so I'm going to say that image of 150 is proportional to the pre-image of 10, which means my k factor, if I divided those two, the zeros would cancel, and my k factor would be 15. So in other words, if the base is 15 times longer, the height should also be 15 times longer. K equals 15. So here if we take and we say K equals 15, that should help us find X. 6 times 15 equals 90. So that flagpole would be 90 feet high. I hope that makes sense to you and that you're grasping the concept. You can use either method on tonight's homework, and I encourage you to do whatever works for you. All right. Oh yeah, I forgot about this slide. I thought that was the last slide, but we'll keep going. I remember this one now. Okay. This one says you got a map, and it says that every 4 inches on your map equals 10 miles in real life. So let's call the 4 inches the pre-image. And let's call the 10 miles the image. So it says, what about for 1 inch? Well, we can use proportions. So if we say that it's proportional, the image of 10 miles to 4 inches is similar to x miles for every 1 inch. All right? So we could cross multiply 1 times 10. Excuse that. 1 times 10 divided by 4 equals x inches. So 1 times 10 is 10. 10 divided by 4 equals 2.5. So x equals 2.5. And like we learned here, it's going to be in miles, or 2.5 miles. All right. So then it says, how far apart are two places 12 inches apart on the map? Last time I used proportions. This time I might use k-factor. So if I was looking for the k-factor, I'd say that image 10 divided by the pre-image of 4. Again, we just did that, so I know that k equals 2.5. So that means for every 1 inch, you get 2.5 miles. So in this time, we have 12 is our pre-image of 12, and we know k-factor is 2.5. So we'll take 12 times 2.5 to get that they would be 30 miles apart. 30 miles apart. And I got that by 2.5 is the k-factor times the 12 inches to get 30 miles. Then it says, how far apart are two cities on the map that are 9 inches apart? 9 inches apart. So, and I could do the same thing. I could say we have 9 inches, and because we already know that the k-factor is 2.5, so we'll do 9 times 2.5 equals, excuse me, let me get back to our slide. 9 times 2.5 equals 22.5 miles. How far apart on a map are two cities that are 25 miles apart? Well, I think that most of you guys in this class are definitely intelligent enough that you could do the opposite process, and instead of multiplying, you could divide by that k-factor. But I'm going to give you another method of how to do this using proportions like we did way up here. So when we do this with proportions, we'll say 10 is to 4, image over the pre-image, as 5, again, image is to pre-image. Okay, so now we do a little bit of cross multiplying, and we're going to get 10x equals 25 times 4. 25 times 4 is 100. 10x, so x equals 10 inches. All right, hope that's all making sense to you. You'll have some similar problems on tonight's homework. The lesson originally stated 1 to 21. As I said earlier, I'm cutting down the amount of homework that you're doing. So tonight, do 1 to 4, 7 to 8, still tackling the same types of problems, 11 to 12, and 17 to 18. 1 to 4, 7 to 8, 11 to 12, and 17 to 18. 4, 20, 20. All right. Have a good night. I thank you so much for listening. Hope that helped. I will see you tomorrow.